Welcome on this lecture, and in this lecture we will discuss some basic concept of organic chemistry. And first of all, you can see that two type of arrows is used for understanding the organic mechanism. Okay, so one is the fully headed arrow, it is represented by this one, and one is represented by half arrow and it is represented by this one. Okay, so you can see the first condition in which a double bond B is present. Okay, so what happened here, the full arrow is used to understand that electron density of this bond goes to the B. Okay, and since electron density goes to the B and since equal sharing of electron takes place between A and B, that's why this bond is formed. And in this condition, what happened here, the bond will be broken down. Okay, so whole electron density goes to the B, so that's why A is converted to del plus and B is converted to del minus. Okay, so it is the basic concept, because bond is broken down, whole electron density goes to the B atom, so that way it is converted to B minus. And since electron density sharing of electron density occur in between A and B, so that's why A is converted to del plus. Okay, it fills the electron deficient condition and it fills electron excess condition. Okay, means it can it wants to complete its octet, because here octet will be incomplete. Okay, and in this, since it is complete, its octet is completely filled, but it also have excess of electrons, so it is able to give one electron to the another species. The second one, if you see, this is the CO. Okay, means if you see carefully that oxygen is much more electronegative as compared to carbon. So what happened here? Here I have used the full headed arrow because the electron density of in between carbon and oxygen, or you can understand that the single bond here break down and the 2 electron goes to the oxygen because it is much more electronegative as compared to C. So that's why the electron density is converted to O minus, and this, since this bond present in between carbon and oxygen, so that's why carbon is converted to C plus. Okay, the next way you can see the CH3 CH double bond CH2. In this, what happened here, CH3 CH and CH2, this single bond is converted to minus charge. Okay, single bond means two, this is the single bond is made up from 2 electrons, so whole density goes towards the carbon center, and from here this tail represents that the electron density goes from this carbon center, so it is converted to positive charge. Okay, so it acts as an electrophile here, it acts as a nucleophile here. Okay, the next one condition you can see in organic synthesis, that homolytic fission and heterolytic fission. So in heterolytic fission, what happened here, in heterolytic fission, since single bond participate to form bond in between A and B, so the both electron, means single bond is made up of 2 electrons, so 2 electron goes towards the B, and that's why A feels positive charge, B feels negative charge. So in this, carbocation and carbanion formation takes place, and this type of fission is called heterolytic fission. The next one is that A and B here, if equal sharing of electron takes place in between A and B, so that's why this type of fission is called homolytic fission, and since here 1 electron goes to each species, so free radical will be formed here. Okay, अब मैं हिंदी में रिपीट कर रहा हूँ, देख लो, सिंगल बॉन्ड आपका बना होता है 2 इलेक्ट्रॉन से, इफ इलेक्ट्रोनेगेटिविटी ऑफ बी इज हायर एज कम्पेयर टू ए, तो क्या होगा, दोनों इलेक्ट्रॉन जो दोनों इलेक्ट्रॉन का इलेक्ट्रॉन डेंसिटी है वो किसके पास चला जाएगा, बी के पास, एंड बी कन्वर्ट हो जाएगा डेल माइनस में, और ए बॉन्ड जो बॉन्ड मेड किसके बीच में बना, ए एंड बी, मतलब जो शेयरिंग ऑफ इलेक्ट्रॉन किनके बीच में, ए एंड बी, क्योंकि इसमें कंट्रीब्यूशन ऑफ ए का भी उतना है जितना कि बी का, सो इलेक्ट्रॉन गोज टुवर्ड्स द बी, सो ए फील्स पॉजिटिव चार्ज. The next one is CO. If you see this is the carbon, this is the oxygen. So here electron density of single bond goes towards the oxygen because it is more electronegative. ये क्या है, electronegative ज़्यादा है as compared to say since bond किसके किसके बीच में, कार्बन और ऑक्सीजन, मतलब इक्वल शेयरिंग ऑफ इलेक्ट्रॉन टेक्स प्लेस इन बिटवीन टू एटम. सो दैट्स वाई क्या होगा यहाँ पे, कार्बन फील्स इलेक्ट्रो पॉजिटिव चार्ज एंड ऑक्सीजन फील इलेक्ट्रो नेगेटिव चार्ज. ओके, द नेक्स्ट वन इज सिमिलर कंडीशन टेक्स प्लेस इन दिस वे, यू कैन अंडरस्टैंड. द नेक्स्ट वन इज, आपको पता होना चाहिए व्हाट इज द हेट्रोलिटिक फिजन एंड व्हाट इज द होमोलिटिक फिजन. तो हेट्रोलिटिक फिजन में क्या होता है कि सिंगल बॉन्ड इन बिटवीन ए एंड बी इज मेड अप ऑफ 2 इलेक्ट्रॉन. तो होता क्या है यहाँ पे, जब क्योंकि 2 इलेक्ट्रॉन पार्टिसिपेट करते हैं बॉन्ड फॉर्मेशन किन के बीच में, ए एंड बी. ठीक है, तो कंट्रीब्यूशन ए का जितना है उतना ही बी का है. तो अगर 2 इलेक्ट्रॉन, ए बॉन्ड ब्रेक होता है, दोनों इलेक्ट्रॉन बी के पास जाते हैं, तो ए किस में कन्वर्ट हो जाएगा प्लस में, क्योंकि इसके पास दोनों इलेक्ट्रॉन लूज कर दिया इसने, एंड बी कन्वर्ट हो जाएगा बी माइनस में. तो इस टाइप के फिजन को हम हेट्रोलिटिक फिजन कहते हैं. दूसरी कंडीशन हो सकता है कि ए का इलेक्ट्रोनेगेटिविटी उतना हो जितना कि बी का, मतलब इक्वल इलेक्ट्रोनेगेटिविटी वाले अगर एटम हैं, देन ए के पास क्या होगा, एक इलेक्ट्रॉन सबके पास चला जाएगा, क्योंकि इक्वल इलेक्ट्रोनेगेटिविटी है दोनों के पास. सो इक्वल शेयरिंग ऑफ इलेक्ट्रॉन टेक्स प्लेस इन सच टाइप ऑफ फिजन, एंड सच टाइप ऑफ फिजन इज कॉल्ड homolytic fission. Okay, so in this condition only half-headed arrow is used because equal sharing takes place in between A and B. So that's why it is converted to half arrows. Okay, so it is a basic concept behind the organic mechanism, and यहाँ से organic chemistry आपका start होता है. तो it is very important for you to understand this concept. Okay, so thank you for watching this video, and if you like this video, then watch my second lecture. Okay, I will make second lecture in a very short way. Okay, so thanks for this, and if you like this video, please like and subscribe. Okay.